follow along. Tri in triangles is the prefix meaning 3. We know that each and every triangle has 3 angles and 3 line segments, all joining together to create a triangle. The first way we're going to classify triangles is based on their line segments and angles. So we're going to draw a tree map, and we're going to start with our first triangle, which is known as an equilateral triangle. I'm going to do my best here to draw a triangle with 3 angles and 3 line segments that are congruent or equal. I can notate that by labeling the 3 congruent line segments or sides of the triangle. They all get the same hash mark showing they are congruent. Secondly, an equilateral triangle has 3 congruent angles, which means each angle measures the same amount. I know that each of these angles in an equilateral triangle are going to equal 60 degrees, always. You might ask, how do you know that each angle is 60 degrees? Well, the interior angles are always going to equal 180 degrees all together. So if I know that this whole triangle's angles equal 180, I can take that 180, divide it by the 3 angles, and I get 60, 60, and 60, which together gives me 180 degrees. Since all 3 angles are less than 90 degrees, these are called acute angles. Equilateral triangles have 3 acute angles. Since all of these sides are congruent, we can call this triangle a regular polygon. If you followed along in the last lesson, we learned that regular polygons have sides that are all equal. The second triangle today is the isosceles triangle. I remember isosceles by the eyes, 2 eyes, meaning 2 congruent sides, and 1 side that is not the same. I've labeled that here with my 2 hash marks and my 2 angle marks. I have 2 line segments that intersect. They are equal, which creates 2 equal angles as well. So we're going to label 2 congruent sides and 2 congruent angles. This is a little bit different than our equilateral triangle. Finally, we're going to label all 3 of these angles also as acute angles. They all measure less than 90 degrees. Our final triangle today is the scalene triangle, which is one of the most fun to draw because you don't have to worry about getting any of your line segments equal because a scalene triangle has 3 line segments that are all different. So in my example here, all 3 line segments are not congruent. They are all different. So I'm going to write no congruent sides for scalene triangles. And if all of the sides are different, then all of the angles will be different, meaning no congruent angles as well. The interesting thing about scalene triangles is that they could be right triangles. Right there, they could have a right angle, which would equal 90 degrees. If one of the angles equaled 90 degrees, we could call it a right triangle, but this is not always. It just depends. If that angle's bigger than 90 degrees, it would not be a right triangle. It would actually be something we call an obtuse triangle. So let's go a little further into the types of angles involved in these triangles. The first angle that we're going to notate is an acute angle. I'm going to write that here. An acute angle is always less than 90 degrees. I remember this by thinking of the word cute. I can write, I'm so cute, meaning acute angles are small, little, and of course less than 90 degrees. If I draw a right angle here, the acute angle is going to fall somewhere inside that right angle. So it could be right there, it could be even a little bit bigger. It's going to fall less than 90 degrees. My second type of angle within a triangle is a right angle. Right angles must equal 90 degrees no matter what. We label right angles by creating a small box to identify that that is a right angle that equals exactly 90 degrees. If an angle exceeds or is larger than a right angle, we call it an obtuse angle. I remember the word obtuse as funny enough, the word obese, meaning greater or larger. So if the angle is greater or larger than 90 degrees, we're going to call that an obtuse angle. We can show that here by again drawing the 90-degree angle, but then drawing an angle that goes outside of that 90 degrees or larger. Obtuse angles are always greater than 90 degrees. We can take these angles and we can identify triangles based on their angles. So we're going to draw one last tree map and identify triangles based on their angles. The first way we can is a right triangle. We're going to draw this one right in the middle. A right triangle is exactly what it sounds like. It has one right angle that equals 90 degrees, always. So in this example, I do my best to draw a right angle. I label it with my box, showing that it is 90 degrees exactly. Since this triangle has one angle that's 90 degrees, the other two angles must be much smaller. So the other two angles are going to be acute angles. I talked about how all triangles equal 180 degrees inside. Well, if half of my triangle already equals 90 degrees, the other two angles have to equal 90 degrees. So if I take that 90 and I split it into two, I'm going to have two acute angles. My second to last triangle is the obtuse triangle. An obtuse triangle has an angle that exceeds 90 degrees. So in this example, I have a larger than 90 degree angle. So if that was a pretend 90 degrees right there, my angle exceeds that or is greater, being an obtuse triangle. An obtuse triangle has one obtuse angle, so it's greater than 90 degrees. And then it has two small angles, or acute angles, meaning they are less than 90 degrees. If I have an obtuse angle, then of course I'm going to have two acute angles, because again, this triangle must add up to 180 degrees. And finally, we have something called an acute triangle. Acute triangles have all acute angles. All three are acute, meaning all three are less than 90 degrees. If I add up all three of the angles, they will again equal 180 degrees, but they all are going to fall less than 90 degrees. So in this example, if that was a 90 degree angle, our acute triangle would have all three angles that fall under that 90 degrees or smaller than that 90 degrees. Finally, we want to remember that the interior angles, so all three of those inside angles, must add up to 180 degrees. I'm going to showcase that here. A few examples to show this. We're going to start with our equilateral triangle on the left-hand side. Now, if I draw an equilateral triangle, and all of my sides and my angles are equal, and this totals up to 180 degrees, I can take that 180 degrees and I can divide it by the three angles and see, okay, what does each angle equal? Because it's an equilateral triangle. And I find that each angle equals 60. 60 plus 60 plus 60 totals 180 degrees for this triangle. My next example is the isosceles triangle. I remember that two sides are equal, meaning two angles are equal as well. Now, this triangle too has to equal 180 degrees. Let's say I told you the top angle is 70 degrees, and I need to figure out the other two angles. I could take away my 70 degrees I would have 110 degrees left, and that 110 needs to fit equally into those last two angles. So I could divide it by 2, and I would get 55. 55 plus 55 plus 70 equals 180 degrees. For my final type of triangle, my scalene triangle, all 3 angles are going to be different. So I'm going to label those each with different hash marks. No matter what, those 3 angles must total up to 180 degrees. In this example, let's say one of my angles is 90, one is 40, and one is 50. It will still add up to 180 degrees. A quick review, our 3 types of triangles are equilateral, isosceles, and scalene. Equilateral has 3 congruent sides and angles. Isosceles only has 2 congruent sides and angles. Scalene has no congruent sides and no congruent angles. Triangles can involve either acute angles, which are smaller than 90 degrees, right angles exactly 90 degrees, or obtuse angles, which are greater than 90 degrees. We can then identify triangles by their angles. If they have a right angle, then it's called a right triangle. If they have one obtuse angle, so one extremely large angle, it's obtuse triangle. And acute triangles have all angles are less than 90 degrees. Don't forget that all triangles, their interior angles add up to 180 degrees.